Hello, everyone. My name is Hashim Afzal, and I'll be joined here today by my teammates Caleb Miller, Thomas Kiefer, and David Blankenship. And today we're proud to bring you our pitch presentation for our fantasy football draft assistant. So, first, a little context for those of you that may not be familiar with fantasy football or don't know how it works. So, fantasy football is an online game which you can play with your friends, in which each of you would draft your own teams and would receive points based on the real life performance of those players that you selected. So 60 million people play fantasy football in North America alone, and that number just keeps on growing every single year. At that point, it becomes more than just watching football. Players become active participants or general managers of their own teams by drafting, trading, and managing their teams on a weekly basis. This engagement has built a multi-billion-dollar industry, from league buy-ins to premium tools that players can purchase, providing them insights, to mobile apps, and even sports betting integrations now. And so, what this results in is that fantasy football isn't just popular, it's a whole cultural phenomenon. People come back every season hungry to win and are willing to invest time and money to get an edge. And so, the demand for smarter, personalized real time draft tools is high, and the market just isn't able to meet that demand currently. So, to target this market need, we've been building a draft assistant to give users smarter, faster, and more confident decisions during their fantasy drafts. We offer smarter, real time draft support by making adaptive, pick by pick recommendations, adjusting on the fly based on custom league settings and how the draft is unfolding before their very pick. Our recommendations are powered by machine learning, so our models are trained on years of historical fantasy data, capturing both player performance trends as well as past user draft behaviors. It also contextualizes decisions in real time to better guide users' next picks. We also provide an interactive interface designed for live drafting. It auto updates with real picks from your league and surfaces only the most relevant suggestions. And most importantly, it provides explainability. Users aren't just told who to pick, but also why, increasing trust in the recommendations that we're providing.
Now, to fully understand our recommender system project, we need to talk about the data that it will be built off of. So we've scraped thousands of rows of NFL fantasy football data from golden standard sources and covered all players and teams from 2018 to 2024 football seasons. This will cover both player performance and fantasy draft statistics, so descriptive ID stats like their name and their team, but also their offensive, defensive, and special team stats with some combined engineered features. And then for each position group, there's specialized feature groupings, and we also include fantasy draft statistics like how many points they've scored in the past, as well as the average draft position across 5 different fantasy football sources. We have it currently in a tall format to capture every season by every player as a row, as it aligns better with our goal of predicting future fantasy point production from past season performance. So now on to our EDA summary. Our initial analysis involved doing missing values tests, outlier analyses, and univariate feature analyses. To the left here, we have an example of some outlier analysis where we can see in the 2022 season, there was actually a game that had to be abandoned between two teams because a player had such a serious cardiac injury that the game had to be abandoned. So going through outlier analyses and picking out interesting examples in the data like this really gave us an idea of what kind of data we would be working with. Further with our EDA, we wanted to start going and reducing the dimension of our dataset once we had all of those features and analyses done. We did this primarily through VIF scoring to try and get some of that multi-collinearity down. And on our left here, we have an example of a late-stage correlation matrix from some of our features. So as you can see, a lot of descriptive features, offensive, defensive stats, and some special teams as well as fantasy scoring and drafting statistics as well. So really just trying to encompass the whole system that we'll be working and building our recommender system off of.
For this project, we selected a wide range of machine learning models to balance simplicity, complexity, and predictive power. We chose linear regression as a simple baseline to benchmark how much our more complex models can actually improve performance. We chose XGBoost regression because of its ability to capture nonlinear relationships and feature interactions very well. Moving up the complexity, we have chosen MLP regression to serve as a lightweight neural network. This may pick up on more complex patterns than a tree-based model. We also plan on creating a stacked model that will combine the predictions from our XGBoost and MLP models. This may improve the overall accuracy and robustness of our modeling. Finally, we want to test a deep neural network that will use a more complex architecture and might pick up on more trends. The variety of our models allows us to test different learning strategies and find the best approach for predicting fantasy football points. So the first model that we've trained is XGBoost regression. This model is showcasing moderate performance at best. The initial modeling is picking up on 53.8% of variation and is producing a prediction that's 58 fantasy points off on average. This suggests that there is room for improvement. The predictions do pass the eye test, however, with top-tier players like Josh Allen, Lamar Jackson, and Amon-Ra St. Brown ranked extremely highly. Interestingly, this model is expecting some young players like Anthony Richardson and Jaden Daniels to have breakout seasons and prove themselves as some of the best players in fantasy football. This shows that our initial model is effectively identifying both elite players that we would expect to be ranked highly, as well as sleeper picks.
With our promising preliminary results, we're now moving on to the next steps. And there's a three-pronged approach to these next steps. First is going to be finalizing our model, continuing to tweak it to see that we have improvements, and making just a better predictor overall. Particularly, we're also going to be looking at choosing between several position-specific models or one large individual model. We're also going to be looking at creating the actual recommender system itself, which is currently in the early stages of development. It's going to include rules that are commonly used in fantasy football to improve the strategy and improve the picks, so that way we can also get kind of a human strategic element to it as well. For example, avoiding quarterbacks early, as well as respecting roster limits, are typically things we're going to have to consider. And finally, we're also going to be looking into creating a dashboard UI that will allow our users to easily and intuitively interface with our model systems without necessarily needing to know code, giving it that mass appeal. Over the course of this project, we've also created a very well built out GitHub repo that archives the different things we've done over the course of this project. First, we have a main branch, which includes our public-facing repository that will ultimately be populated by our final product. We have the EDA branch that includes our exploratory data analysis. We have our acquisition and preprocessing branch, which includes scripts for web scraping, cleaning, and just generally creating our data format. We have the modeling branch, which includes our model runs and our model development so that we can test and try a bunch of different models. And then we have our recommender system branch, which is our newest branch that's including our knowledge-based rule system that'll help us assist in our player recommendations, and will ultimately include our dashboard once we've developed it. Thank you very much for listening to our presentation, and now begins our question and answer portion.